Hi everyone, Mr. Boltri here, bringing you the first video of Unit 2, where we're just going to be introducing the very basics of forces. Hopefully this is a reminder, so we're going to go through it pretty fast. And then in our next class, we're going to start diving deeper into kind of what forces are and what they do. So in this video, we're going to talk about a basic definition of a force. We're going to talk about some common forces that we're going to be dealing with in this class. And then we're going to go through the rules for how to make a force diagram. So try to think back to freshman year and just your experience in the world and think about what is a force? Give me like your best definition. And so the definition that I found on the internet is that the force is a mysterious energy field created by life that binds the galaxy together. Oh, shoot. I think that was actually the definition for the force. But in this class, we're going to be focusing more on a force or forces in general. And a force is a push or pull. Kind of basically, it's a push or pull. And we can be more specific than that and say that a force is a push or pull by one object on another object. So when we're looking at forces, there always has to be a by and an on, something doing the force and something receiving the force. So one way that we're going to be able to determine whether or not something is a force is if we can find something doing it and something receiving it, the push or the pull, that is the force. So again, think back to your experience in the world and list for me as many forces of which you are aware. So I came up with this big list of forces, and these are forces that we're going to be focusing on in this class. There are other forces too, which we will not really be focusing on, but here is a list of a whole bunch of forces. So there's the force friction, which is like two surfaces rubbing against each other. There's force drag, which is like the friction when you're hitting a bunch of like air particles, or it also applies to water too. So you'll often see F air when it's the specifically air drag, or just FD for drag in general. Force tension is like when you're pulling on a rope. And then force springy or force elastic is when you're pulling on something stretchy. And the difference between force tension and the spring force or the springy force, because it's not just springs that have the spring force. So normally you'll see force spring, but I call it force springy because it's anything that's stretchy. Is force tension, the medium, which is like the rope or whatever, does not stretch, does not deform, does not change in length. And for something springy like a spring, it actually will change in length as you're pulling on it. So that's how you tell the difference between a tension force and a spring force. Buoyant force and normal force are similar, but buoyant force is for something that's like floating on top of water. The water's like pushing it up. And normal force is for something that's like sitting on a solid surface. The solid surface is pushing it up. Like a table is the easiest example. And then force applied is like our catch-all force for any like if I were to push Mr. Taylor, that would be an applied force by me on Mr. Taylor. So some other forces are force gravity, which we all know is caused by the center of the earth pulling us down. Some of my freshmen thought it was like the column of air on top of you, like pushing down on your head. And that's not true. It's by the mass of the center of the earth sort of pulling you towards the center of the earth. And then this course was not really going to focus on the magnetic or electrical force because that's for the E&M course. But just so you know that they do exist, a magnetic force and electrical force, and they're related, and it's this whole big cool thing. And then there's a whole course about it. So then there's also inertia, momentum, velocity, acceleration, and energy. So I've divided these into three categories. I have the blue over on the left, the green in the top right, and the red in the bottom right. And I just play a little game of try to guess what the different categories are. What do I mean? Why did I group all these blue ones together as separate from all the green ones? Why are the green ones together? And then why are the red ones together? So I don't know, maybe you guessed it, maybe you didn't, but here are the kind of ways that I think about these forces or not forces. Let's start with the ones in the bottom right. These are not forces. So students will try to say that some of these are forces, and they are not. If you list it on a force diagram, you are wrong because these are not forces. These are other physical quantities, and many of them, if not all of them, are connected to forces, but they are not forces in themselves. They do not meet the definition that we established earlier of what is a force. So then when we look at forces, we can call one way to sort of differentiate between forces is to look at contact forces and non-contact forces. So to do a contact force, you must be in contact with the other thing. So if they are not touching, then they are not doing any of these forces. But non-contact, specifically gravity, like I am not touching the center of the earth right now. I'm not in contact with it. Even if you jump up in the air, you're not in contact. So gravity can act over a distance. It's like this magical ability that none of these other contact forces have, because it's a non-contact force. Okay. So now that we have sort of some of just the very basics of the forces that we're going to be looking at in this class and the not forces that we're going to be looking at in this class, let's talk about how to make a force diagram. So a problem might look something like this. It's just here, there's a book. It's sitting on a table, and make the force diagram. Most often, force diagrams are useful for us to solve other problems, but you might be asked just to make a force diagram in like part A of an FRQ, just to help you in the other parts and so that they can make sure that you know how to make a force diagram. So we're going to go through some of the rules for how to do that. So the first rule is we want to always draw a system boundary, and that is just a dashed line that clearly denotes, clearly demarcates, we are drawing the forces on this book and only on this book. So we're going to draw any forces that are like external forces and ignore internal forces. That's kind of why it's important that we decide what is inside the system and what is outside the system. So you'll notice that, for example, the air is outside the system, the table is outside the system, the earth is outside the system. So those are going to all be giving us external forces. Okay, we're going to go 2 in a row now. So first, we're going to represent the object using a dot or a box. So you see here, I chose the box method. Either one works. You do not have to label it inside the box. I just did to help you remember that this box represents the book. And so then next is we're going to show forces starting at the object and then radiating outwards. So here, this is a good way to show the force. It starts at the object and radiates outward. This is a bad way to show a force. It starts over here and radiates towards the object. This is just a convention so that we always know where to look for the forces. So it always starts at the object and then radiates outward, either up, down, left, right, or at an angle. It's all fine. It just always needs to start at the object. Okay, so next is, so the length of your arrows matters. So the longer the arrow, the bigger the force. So if this force normal were to be tiny and the force gravity were to be huge, that would mean that there's more force gravity than there is force normal. But you see here, they're approximately the same length, and I have these equality marks, which means that they are equal length. That's just to make sure that anyone looking at your force diagram knows exactly how long your arrow is supposed to be. And then last but not least, make sure that you label all of your forces. So here I have force grav and force norm. You can use any of the abbreviations you saw on the previous slide, like I could do FN and FG. That's fine too, but just make sure that your forces are always labeled. They're not just like random arrows just hanging out in the middle of nowhere. And you can omit negligible forces, like if something is falling with negligible air resistance, you would not add the negligible air resistance. So that's kind of just like the very basics of force diagrams. We are going to draw a lot of force diagrams this unit because they are like the most helpful thing to help us figure out some force problems. So we're going to get lots of practice with this. This was just a brief refresher of what you hopefully remember from a couple of years ago. And if you don't, then we're going to practice a lot. So let me know if you have any questions. And then in our next class, we are going to do a whole activity where we investigate forces, what forces do, and we're going to draw force diagrams and practice all of that. So this is Mr. Boltri wrapping up video 2.1, where we talked about the very basics of forces and how we're going to be using forces this unit. Go Bears.